Hello, welcome to Chapter 6, where we're going to be working in Section 3. We're going to be talking about dividing polynomials. Just a little bit of background information with this one before we actually show you how to do it. So, in Algebra 1, that's where we learn to add polynomials. We start with the idea of adding what we call like terms, but that actually kind of doesn't make sense. We don't really know what like terms are. Along the same time, I mean, we do. It's just if I just said, "Hey, just add like terms," we have to explain what that means. All right, that's what I meant by that. It's kind of a phrase that doesn't really. It's not intuitive for anything else. Along the way, after we learn how to add, we know that subtracting just means you're going to add the opposite. So if I was going to subtract polynomials, I just change it into a addition problem, and I change positive to negative, negative to positive for the things I'm going to subtract. We also learn at the same time, not at the same time, sorry, but during that same section, I suppose, how to multiply polynomials. And we've done a little bit of that in Algebra 2. Adding, subtracting, these are things that we expect you to know in Algebra 2. Multiplying, we review it a little bit, but again, this is all stuff that comes when you learn Algebra 1. Now, at the time, when I teach Algebra 1, I explain that, if we do adding, subtracting, we do multiplying, what about dividing? And I tell my Algebra 1 students, that happens in Algebra 2. Well, guess what? This is Algebra 2. So this is where we're going to talk about dividing polynomials. Dividing polynomials is different than factoring polynomials. They're very, 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 very similar. They're both working backwards from multiplying. The difference is when I divide, whether it's a polynomial or even dividing just constants, numbers. When I divide, I'm going to divide by something. So for example, if I said I want you to factor the number 12, you would say that's 1 times 12, 2 times 6, or 3 times 4, if you want to get factor pairs. If I said I want you to completely factor 12, you would say 2 times 2 times 3. However, if I said I want you to divide 12, I have to follow that up with by. So I want you to divide 12 by 4. And then I would get 3, the other factor pair. So the big difference is factoring, I'm going to break it into what multiplies to give the number or the polynomial. And dividing, I'm going to get factor pairs, and that's going to be part of it, but I'm going to give you one of those factor pairs. So we're going to explore in this section 3 ways to divide polynomials. The first way, we're going to use what we call long division. And in class, we will have a little discussion about, I'm not going to put it in the video because I'm always mindful of the time. I'm already 3 minutes, I haven't even started doing any problems. But in class, we will compare this to long division of just numbers. And we'll especially talk about some of the things to look out for. Excuse me. But long division is, I don't know if elementary school teachers still teach long division. I assume that they probably do. And I know that that was something that my teachers just killed me with. I think that was the first time I ever looked at a worksheet when I was in the 5th grade, and I'm like, all right, I think we get it. It was like, 100, it must have been 1,000 problems of long division. I'm exaggerating. But anyway, hopefully I'll be able to make the connection between what you know already and what I'm going to teach you now. So for this video, I'm going to show you how to do it with polynomials. All right, how to do the long division with polynomials. So let's look at this first example. Let me line that up. That's been bugging me. So I've got this quadratic trinomial, 15x to the second power plus 8x subtract 12. And I'm going to divide by 3x plus 1. Now I want to mention one thing. This right here, this symbol, looks like this. Some people said, oh, it's a fraction with dots in the numerator and denominator. Actually, I don't know if that's true, but that's a cool way of saying it. This is called an obelus. And I have been trying to avoid using the obelisk for a long time because it causes confusion. And actually, when looking on the internet to see if people were agreeing with me, the System International, the SI, has a recommendation of what symbols to use, and they are asking that scientists, engineers, mathematicians are going to avoid this. So we're going to try to avoid it when we can, but in this case, it kind of makes it a little bit easier if we just remember that it does mean division. So if you ever hear me say don't use that, and now here I am using it, I kind of feel like a hypocrite, but it'll be okay. All right, so we're going to do long division. Here's how this works. I start by taking this polynomial, 15x to the second power, plus 8x, subtract 12. And I don't know if you remember this when we do long division, but it looks like that. And I'm going to write the 3x plus 1 right here. And like I said, I will do an example of long division when we're together in class with numbers, without polynomial, with actual numbers. So here's what I do. I got to look at the 3x and I got to look at the 15x squared. I'm just thinking, and I'm going to write this over here. So what I'm thinking about is 3x times what is going to equal 15x to the second power. What do I multiply 3 by and I get 15? What do I multiply x by and I get x to the second power? Well, that shouldn't be too hard. 3 times 5 equals 15, and x times x equals x to the second power. So if I multiply 3x times 5x, I get 15x squared. And if I work backwards dividing, if I divide 15x squared by 3x, I guess I could have written it this way, 15x squared divided by 3x, and that's going to give me the 5x that I was looking for. I'm going to put that 5x right here. Now, this is where it gets a little tricky, so pause it, rewind it if you need to. I'm going to multiply not just the 3x by 5x, but I'm actually going to multiply 3x times 5x and 1 times 5x. So I guess I could have written it this way. I'm going to multiply 5x times 3x plus 1. And again, don't worry about this over here. Sometimes it's easy in the videos, not easy, but sometimes it's nice in the videos if I show you what I'm thinking. That's just what's in my head. So if I multiply 5x times 3x, I get the 15x squared. I'm going to put that right here. And if you remember long division, what I multiply the top and this by, I put below it, and then I'm going to subtract. 5x times 1 is going to be 5x. Now here's something that's tricky. Notice I didn't put plus 5x. Here's why. If I do not put a sign in front of it, that means that it's already positive. So positive 5 times positive 3 is positive 15. Positive 5 times positive 1 is positive 5. Got it? However, if you remember from arithmetic long division, now I'm going to subtract. Subtraction means adding the opposite. So I'm going to change the sign and change the sign of both of those. So I'm going to take 5x times 3x plus 1 and get 15x squared plus 5x, and then I'm going to subtract that, which changes the sign of both terms. I'm going to total that up. 15x squared subtract 5x squared is 0. You can put a 0 here, 0x squared even, but you don't need to. 8x subtract 5x is going to be 3x. Now, again, you can always show the hidden stuff. I also have a plus 0 right here. I'm not going to write it because I'm using a marker. If I was using a pencil, I'd write it and then I'd erase it. But I also have a plus 0, so I'm going to add everything here to this, and the negative 12 plus 0 is just negative 12. What I've heard teachers say in the past, and I'll probably slip and say this, is you subtract, and then you bring this down. I don't think bringing, quote-unquote, bringing it down explains the math behind it, but I know that you've heard that before, so maybe that might make sense. Cool. Now I do the same thing over again. I take that 3x, just the beginning. I'll take care of the 3x plus 1, the whole thing in a moment. But I say 3x, what do I multiply 3x by that equals 3x? Well, that should kind of be easy. That's just 1. So 1 times 3x is 3x. That takes care of the leading part of it. And 1 times 1 equals 1. Again, both of these are positive at this moment. 1 times 3x is positive 3x. Positive 1 times positive 1 is positive 1. Just like last time, I'm going to subtract. And when I subtract, negative 12 subtract 1 is negative 13. All right, now, what would really be cool is if I got a 0 here, because this is what we call the remainder. And it might have been a long time since you've actually talked about remainders. And if we were doing this, like I said, with arithmetic, with whole numbers, for example, if I got a remainder, then I would start to switch that over and probably figure it out as a decimal. Okay, so I'd keep going. I'd put more decimal places in it. Well, since I'm using a polynomial, I don't have that option. So here's how I do it. Remember, I'm going to be dividing everything. I'm going to take 15x squared plus 8x subtract 12, and I'm dividing by 3x plus 1. So what ended up happening was I got this little extra bit, this extra negative 13. So I'm going to divide this by 3x plus 1. And here's what to do with the remainder. I take the negative 13 and I divide it by 3x plus 1. And I take this part, I'm going to put a little cloud around it because that's not part of my answer. But I take this negative 13 divided by 3x plus 1 and I add it up here. Oh, sorry, negative. Whoa, man, don't do that. This is why you don't use a marker, kids. 3x plus 1. So it's negative. So I make it into a fraction and I add that fraction onto the end of my quotient, 5x plus 1. Okay, as always, pause it, rewind it if you need to, but I am going to switch and do another problem. All right, so again, I have 4x squared plus 3x cubed plus 10 divided by x minus 2. Now, we're going to want to do this. I'm going to put it over here in the corner, and then I'm going to ignore it. We're going to want to do this. 4x squared plus 3x cubed plus 10. We're going to divide that by x subtract 2. Don't do that. This was not an issue with the first problem where I showed you how to do long division, but it's going to be an issue with this one. I didn't mention it with the first one because it was set up that way, and I know that I didn't want it to be distracting. So I'm going to modify what we did or what we need to do from now on. Both of my polynomials that I have here have to, first of all, they need to be in standard form, which means that the term that has the highest exponent comes first. So I need to put the 3x to the third power in front of the 4x to the second power. But not only that, I also have to include the missing terms. And what do I mean by missing terms? The polynomial actually kind of represents what we call place value when we have numbers. So you can think of it as if x was 10, this would be 3 times 10 to the third power, which is 3,000, 4 times 10 to the second power, which is 400, so 3,000 comes before 400, and I don't have any x's. I have 0 times x, and then of course I've got 10, which kind of throws it all off. The reason why I said 10 is because we got 10 fingers. That's how we count. So I need to put a space in there for the 10 spot if I was talking about numbers, all right, base 10. I'm not talking about numbers or base 10. Well, I'm talking about numbers. It's a polynomial. But I'm not talking about base 10. This is base x, whatever that is. So I have to do this. I'm first going to write the 3x to the third power, because that's the highest exponent. Then I'm going to write 4x to the second power, because that comes next. 3, 2, and the next term has to have x to the first power, also known as just x. I don't have anything up here that shows me that. So I have to write 0 times x, or 0 times x to the first power. And then, of course, I get plus 10 as my constant. So that's the missing term that I need to put in there. That went a little high. Now everything else is going to occur just like we did before. What do I multiply x by that equals 3x to the third power? That's going to be 3 times 1 is 3, x to the second power. X to the second power times x is x to the third power. And over here, again, this is what I'm thinking. If I multiply 3x squared times x subtract 2, so I'm going to multiply that times that, I'm going to get 3x cubed. X squared times x is x cubed. And 3 times negative 2 is negative 6 x to the second power. So oftentimes students will say, yeah, you multiply that times that to get that, but what happens here? You still multiply that times that. The only thing is you get this negative 6x squared in this example, and then I'm going to add that to the 4x squared. Except before I do that, remember that I have to subtract. So I'm going to change positive 3x cubed to negative 3x cubed, and I'm going to change negative 6x squared to positive 6x squared. I'm subtracting, so I have to change the sign. 4 plus 6 is 10, and I get 10x squared. And I am going to, and I said I'd probably say this, so I'm conscious of it, I'm going to bring down the 0 times x, which basically means if I put plus 0 here, I'm just going to add it to 0. Okay, so I still get 0x. Why is that important? All right, what do I multiply what do I multiply x by that equals 10x squared? Well, that's going to be 10 times the other x. And 10 times x minus 2 is going to be 10x squared, which is what I want. And 10x times negative 2 is going to be negative 20x. Keep in mind that I have to subtract, so I'm going to change the sign and change the sign, and I'm going to get positive 20x. Now that's why I need to put that space in there, because if I end up with getting this subtracting negative 20x, I need to add that to something. That's why I have to have that in there. I need a place for everything. So again, I'm adding 0 here at the end, so 10 plus 0 is going to give me my 10, or you can just say bring it down. I don't like doing the bring it down. It makes it seem like there's a trick to it. It's not. What do I multiply x by that equals 20x? That's going to be 20. So 20 times x minus 2 is going to be 20x subtract 20 times 2, which is 40. And just like here and here, I have to subtract this. So change the sign, and I get 50. And that is my remainder. I have used up all the terms right up here. So my final answer, 50 over x subtract 2. Alright, I know this video is getting a little longer because it's usually in the first videos I do a lot of talking about what you're going to be learning. So thank you for doing that. I'm almost at like as long as the episode of The Big Bang Theory. We're going to do one more here. Oh, I hope nope, sorry. The 5 and the 28. The first problem we had a 15 and an 8. Sorry, I was thinking maybe I accidentally put the same one twice. Nope, we're good. So this is in standard form. and I have a term for each. I have x to the second power, x to the first power, and I have my constant, which is actually x to the 0 power, but we'll talk about that later. So I have x to the second power plus 5x, subtract 28, and I'm going to divide by x subtract 3. What do I multiply x by, and I get x to the second power? That's another x. So x times x subtract 3 excuse me, is going to be x squared subtract 3x. I'm going to take this polynomial, x squared subtract 3x, and I'm going to subtract the whole thing. That means I'm going to add the opposite of both of them. 5x plus 3x equals 8x. Just think of it as adding 0, so negative 28 plus 0 is going to be negative 28. What do I multiply x by that equals 8x? That's going to be 8. So 8 times x minus 3, excuse me, get a little dry here, is going to be 8x subtract 24. And as every time, I'm going to subtract this, so I change the sign, change both of them. So positive became negative and negative became positive. And I end up with the remainder of negative 4. So I'm going to put that remainder up here. I'm going to do plus negative 4 over x subtract 3. It's the remainder in a fraction with that in the denominator. Okay, I will be doing more of these in the guided practice problems and probably talking about them a lot in class. But please rewind it, watch it again if you need to, ask questions in class.